Okay. We'll go ahead and get started, and a little bit of housekeeping. I want to make sure we're on top of. Now, each week as we've worked through, we worked through these first access workshops, and then we started working on the lunches database cases. And as I look back for and you remember I do two parts of these. The first part is ground-based, and then the second part, let's see this. I don't want to do that. And the second part of it is, of course, what substitutes for your virtual time. And so that's why you're always going to see a part one and a part two. But last week, we ended up the part two, and I record that usually over the weekend. That was, we were working with, we finished off lunches database number 6. So we'll start on 7 tonight. And I get a couple of emails of some folks that seem to be confused. And I think it was I'm not sure, I think it was a combination of maybe just not watching the videos or whatever. But that being said, these are the files that you were to turn in each time as we did one of the access workshops. And there's an uploads file over in Canvas that outlines all these. Now, on the fourth one, I'll let you turn that in, or there was a WM-CRM combined data that I was fine with you turning in on for the access workshop number 4. But that's where we worked with that Northwind Traders database, took it apart. We worked with a couple of exports on those. When we did the geographic sales, we took their geographic data and went out and mapped it. We did the fact sales. We pulled that out as we talked about what we call a fact table, and we talked about dimensions and tables and all that stuff as kind of a prelude to where we were going in terms of the lunches databases. Now, lunches database cases are all over there in the Patrick materials, and there's a zip file that has those cases. Well, it has two things. One of them, and I'll just go ahead and take you down to my desktop and show you. And this is just repeating what I've already said before. Still find the Patrick materials over here, and I'll show you what I'm talking about. Here you are. Now, this typically will have an SQL file. Okay, that's the data warehouse. It has all the tables. And then you'll see this zip file that's got the SQL, the code for all those. Now, there's also a sales database in there, and I had taken it, and here on my desktop, I had taken it out, but that's the complete package. And so everybody should have been on top of that. If you had some confusion, I'm not sure what to tell you other than maybe watch the video and pay a little more attention or something. That all being said, these are due at, they were due at 6 p.m. or 5 p.m. Let me pop on here for a sec. And all of these were to get us acquainted with the idea of a data warehouse and information design so that we start to understand what we're trying to do with the database and what we're trying to accomplish. And we talked about that. We talked about the wisdom triangle. And then we talked about data marts, and we talked about using exports and so forth to use the database for what it's best at doing, and that is storing and making accessible information, data that we can turn into information to make decisions. That's pretty much it. And judging from a lot of submissions, a lot of folks, I think are on target. Now, this week we're going to work on Lunches Database 7, and then each week as I work through these, okay? I'm going to have, I'll have something that you can upload, for example, like 2, and this is Lynch's database 3. So I'll typically will have a file that we'll work on, and I say, okay, upload it. And it's a good idea when you do to upload it. And what we're doing is we're working with the code a little bit, and as we walk through the text, we're going to use it. We're going to be using it to see some different pieces of using the SQL, using the GUI, etc. Now, I'm going to whip back over to my office for just a quick second because I forgot to bring my textbook. I'm chatting everybody about that. I apologize. I'm getting spoiled by having digital textbooks and not having to lug this thing around. I guess if I needed it for self-defense, it'll work for that. Otherwise, now, like I was saying before, contractually, we're obligated to tell you to use the bookstore. Frankly, if you can rent it and be done with it. Because I think the rentals on these are usually 6 months, which is more than enough time. Now, if you have the Patrick text with you, or in digital form, we're over on 7 and chapter 7. That starts on page 245. Now, what's going on is we're just simply adding a little bit more layer of complexity. In 6, we talked about creating tables, okay? Just something to store tables down. Again, it's important that you understand a table and what it's meant to do so that you can communicate effectively with the IT people when maybe you're doing a revision of your database or they're asking for some additional input. A table is very simply, it's a collection of records. Those records are dimensions like last name, first name, etc. A good table is like a paragraph. It has one subject only. It should have, say, customer contact data, customer sales, that would be a fact table, but customer contact data, product attributes tables, etc. And then we link those tables together so that we can create some output. We also have fact tables, which are typically going to be tables that are they're really nothing more than transactions. But there are 2 things that we're after here. One, we want to see how our transactions are being handled internally, okay, so that if there are any issues. And number 2, we're going to be probably focusing on a lot of emphasis upon sales transactions. Now that can go everything from, somebody comes in and they buy something and write me a check to they punch their card into an ATM and it's uploaded and all that business. The payment interfaces are all changing. And of course, many of you probably a large number of you bank by phone. You make payments by phone. Asia has a way that if you want a loan or you want to pay your friend $20, they've got little apps that you can punch that and you send the money to your friend. All of this stuff, because the technology is all changing, but it's also being driven primarily by mobile computing, okay? And so those, as we try to kind of adjust all of this, it becomes and because it becomes far more real time, and it becomes more incumbent upon us to understand when we build a table that we're not just getting a hodgepodge or grab bag of information, but that we really focus that table on one subject, just like I would a paragraph. And we have a collection of the key attributes of our customers, well, all of our key stakeholders. And that's what you need to know. Now, to see these and to run the SQL is good for you, because as you see that kind of unfold, number one, I think it's just good for your mental acuity, because it improves your critical thinking. It makes you think a lot clearer, a lot more directly than maybe you would otherwise. And number two, it gives you an experience base to say to a prospective employer, yeah, I've worked with it. Okay, just like you've worked with SAS, you work with SAP, or you work with Oracle. And as I said before, in one of these, at the end of the book, you have the opportunity, if you want, to download a baby Oracle and play around with it. Everybody and you'll hear me say this over and over and over till you're tired of it, but it's true. Everybody who comes out of business school today knows how to work with spreadsheets. Where you have an advantage, a competitive advantage, is that you come out and you can understand and use databases. If you see those things and you understand them, okay, and you understand what a database can do for you and not do, and you can communicate effectively with the IT people, you are way ahead of your compatriots out there in terms of your ability to contribute to your employer. And then as these things get pulled together into what I call hybrid types of applications, it just becomes more and more incumbent upon you to have an understanding of that. Okay, so we're going to work on Lunch's Database 7, and you should always have your textbook with you. This is the textbook. You got it? Because this will give some context. If you don't bring it, you really aren't going to get the best of it, because you're not going to be able to see this in context, and you really do need to. Chapter 7 talks about formats, sequences, and indexes, okay? And so what we're really talking about is, how do I arrange, once I've built tables, how do I arrange them such that I can access data as fast and as easy as possible, okay? Now, they're over on page 246. They walk through the formatting dates and then other formats. So I'm going to go here, and I've got it on my desktop, but I'm going to go into chapter 7 of the Patrick materials. I'm going to get those data, and I'll get the chapter 7 code. Okay, and I'm going to open it up a little bit. And then I'm going to go ahead, and I've got there's Lunch's DB6. So I'm going to go ahead and just take, I'm going to open that up again. And I'm going to copy this and make it Lunch's DB7. So I've got it there, and I'll just rename it, and then we'll do the work. Now, we got that Lunch's DB, so I'm going to call it 7, and they'll open it up. There we go. I got it. We're fine. And it'll enable the editing. Okay, now you'll want to make sure that you could save these as we work through them. Now, I want to show you something here as I open this up. Okay. They're going to start to give us some issues about formatting of dates. Here's the problem with dates. It's very simple. A computer is a machine. Machines are really good at handling numbers. They're not so good at handling text. You have to train them to do that, because they just simply they don't function like that. And so when we work with dates, we have to make sure that we format them in a way that works for the machine and gets us the output that we want. And that's really about all there is to it. Now, it is a key issue for you, because if you're involved, say, in putting together a new database, or maybe maybe they say, okay, we want to create a database for this region, then you need to be mindful of dates and how they're formatted so that you can have them put in there properly and you could use them. And the authors talk about that, and they give us this first query, 7.2, okay? And you're going to notice something. Now, one of the things that should be happening if you're paying attention as we go through these exercises each week is you should start to quickly recognize the syntax or the structure of each of these queries. Let's take a look at this first one. You've got select the employee ID, okay? First name, then a hire date. Then notice we've got the format quote that's used here, okay? And then they put that in parentheses, and you have the hire date, and then they put in the formatting for that date, and they give it, and then they give it as formatted date, and that's that anonymous name or alias name that we give to a column, i.e. a dimension from the employees, and we order it by employee ID. Okay? Now, let's take a look at that, and I think it's not going to play nice with us because it doesn't like the format command, but let's see what happens. So I'm going to go ahead and copy that code. My hunch is it's not going to play nice. Let's see. Yeah, that's what I figured we would get. So there you'd have to come in and you would have to go ahead and just use those single quotes to clean that up and get rid of the format part there, because it's just not gonna recognize it. And right there you can see you've got an issue just trying to display it. Now over there in chapter 250, page 250, excuse me, if you take a look, we just ran that query. It's supposed to work and it's not, and it's because that format command no longer works with SQL. So you'd have to do a little bit of adjustment, okay, to just simply have it pull up those the employee ID, the first name, and then the hire date, and it should be in a format. And let's do this. I'm going to take my cursor and I'm going to take that out, and I'm just going to call hire date, and we'll get the comma. Let's go ahead and I'm not going to do the column alias. And let's pull this up just to here, and let's see what we get by getting rid of all of that. We still may have some problems, and these are one of the headaches that we run into when these folks decide. We've got to reserve from employees. Okay. I didn't need I didn't need the comment for that. There we go. Now, you said, well, how would I change this if I want to change it into something other than this format? It's very simple. You use the graphic user interface. That is, you go into the table, you go into the dimension, you go into the table, you go into the design view, and you can choose the format that works best. Okay? That's all you have to do. You're not database administrators, so you won't have to encounter that. And as I said before, the tables that you have access, the tables that you can utilize for queries are going to be based upon the number of reports or your report structure in terms of where you sit in the food chain in terms of management. Top managers can have access to everything. Lower level people, that's going to be something that's going to be restricted by the company based upon what they think is your need to be able to run the queries. Now, when we had the Northwind Traders, you'll notice when we opened it up, there was a dashboard, and we were told here, and basically the message was implicitly, this is all that we're going to let you see because this is all you need to see. And that's a security thing as much as is possible. So we're just going to go ahead and call this 7.2. I'm going to save it as such. And notice I just did a little bit of work there. And on the hire date, what we did was he took the access SQL in the middle of page 250, and I got rid of the format command. It's not working anymore in access. And I just brought it on up to the hire date. Now, if I want that changed, it's simple. I can go back into the table I pulled this from and change the employees, which is where I pulled this from the employees table, so I can go back to employees, change the formatting there if I wish to, and away I go. So I've got 7.2. And let's look at the design view, and there we be. Okay? No big deal. The issue with the formatting and why it's so important is you getting the information in a way that you want to see it and it makes sense. Then secondly, it's because it costs money. If you're handling 10 million records and up, and that's easy to do if you get to a medium-sized company, it starts to cost you some real money if you've got everything formatted out to the max, especially fields where you use characters or what we call variable characters, which can be a letter, a number, a blank, some kind of special symbol. If I've got too much space allocated, I'm just paying money. It's going out the door, and I'm just really not doing myself any good. I'm wasting the money. That's all there is to it. Now, 252 and 253, they walk you through another, and this, the bottom of page 252 is an insert. So let's pull that code up for just a second and take a look at it. And all we're going to do is insert this into this table, and then we have the values we're going to insert into it. Now, again, insert queries, wonderful, but yeah, as I've said over and over, you really do want to insert data using a form where it's completely controlled, where you have the kind of where you have the integrity in the data, you have it in the format and the amount that you want. So if you don't want nulls, they're not there. If you have a certain number of characters, it's there, etc. You use things like input masks. I want to show you that for just a second to kind of refresh your memory. Here's the table, and let's go in the tables and click on the employees table and take a look at it for just a second, okay? And as I said before, tables like a paragraph, it's one subject, and this is everything about our employees we want to know. Their ID, their first name, their last name, department code, the hire date, credit limit, phone number, blah, blah. Now, there probably in reality would be another table of employee sales records. There might be a table of employee payroll for this particular, for these employees, etc. But here we're just dealing with contact data and their manager, okay? Now, I'm going to right click it and go into the design view. And if I want this in a particular, if I want this in a particular format, it's simple, like hire date, okay? It's in date and time, all right? And if I want to, I can use an input mask. Click on the hire date, and you should be able to see me, and then click on the input mask, and you'll get a little drop-down menu that lets you have the time inserted in a way that you prefer. Most commercial products today, that's how they operate. You don't write the code to deal with it. It's just it's nonsense. It's a lot of extra work. Same thing with all these inserts that he has you run. You're going to have forms to put those into. This input mask wizard. You can see you can format these data however you want them. And in fact, if you want to try it, if you say you're going to choose that one, I'll let you go down there and see what it's going to look like. That's all it's about. And let's come down to phone number and click on the input mask there. Same story. And I'm not going to save the table. Well, yeah, why not? And there are the phone ways in which we can have those phone numbers entered. We can even have them in for password format. You'll notice something these days as you're logging in. Think about for a moment when you log into OBU email, you'll put in your email and you can see it, and then you don't see your password. And what's happened is that people are having trouble remembering their username and their password, so they get a kind of a hint, and most of the time it's an email or something like that. So no biggie there. So finish it off. Okay. Now, at 7.3, they show you the bottom there of doing that insert. I don't know if it's really worth it or not, but why not? Let's try it. And so I'm going to go ahead and grab that code, and I'm going to insert that into the lunches table. Now, each of these values, there should be, it's best for you to have an equal number of values to the equal number of columns. Look at the very last part of 7.3. Can somebody tell me what's going on there? What are we looking at? What do you think? What word is there? What's the word? There's a word there. What is the word? Is anyone tell me? No, I'm on 7.3. The last word, there's a word in there. Now. And now is a function, which means that what it's going to do is that the last thing that will show up in that insert is going to be right now. It'll tell you the day and the time. It'll give you a day and time stamp. That's all it is. It's the now function. And so if you want a day and time stamp, boom, it'll tell you now. And this is it's a security feature, it's a convenience feature. That's all it is. So I'm going to do Control C that. Let's run it and see what we end up with. Like I said, most of this stuff, it says you're about to append a row, and I'm about to insert this into this table, these values, and there we go. And then we can go down and look at that 703 lunches, and you'll see those values, and then you'll see now. Now you add that on there if you wish, so that you have the date and time stamp. That's all he's trying to show you. Okay. Over on page 255, the author talks about the GUI and using it and setting field properties, and we've done that. But you know, let's call it. This will be. I think this is going to be 7.3. I think unless I'm mistaken, so we'll call it 7.3. And then we'll go back and we'll back through the tables. Now we've covered some of this a little bit if you took 1123. But let's go down to the design view. And the essentials on this are the data type, okay, the field size, the precision if you're going to have decimals, how far out do you go, the scale. The decimal places to say are automatic, and they've got a field size, a precision of 3, an input mask if you want to add that, caption. A caption is a way to hide the true name of the column or the field if you want to do so for security purposes. And it just becomes an issue if you go down there, validation rules, etc. The key part is is whether or not it's indexed. And it says, yes, it's indexed, no duplicates. The indexing is important for a real simple reason. When you have a database that's indexed, it knows how to conduct a search far quicker and more efficiently than it would otherwise. If you don't have it indexed, it will just simply go row by row by row by row by row till it runs through all 100,000 rows. Whereas if you have it indexed, then it's going, if you have it indexed, then the underlying, what they call the jet engine for this software for Access, or the underlying machine language for any other commercial product, it's going to take that machine, it's going to go right to the heart of where you would find the most probable results. If you're looking for names or numbers or anything that's alphabetical, it's going to go right to that clump of letters where the most names are at, or most words are at, and they're there. And it will just simply follow that, so it does a far more efficient search. That's really what it's all about. That's all. And they have you run some SQL there on 7.5. At the bottom of at the bottom of page 255, you're going to see again the format. They use the format, and it's just not going to do right. If you really want to work with the format on that phone, okay, you can go in and we'll click on phone number, and you could come in and use an input mask so that the phone numbers are in a way that you want to see them. Plus, they're also occupying an amount of space that you're okay with paying for. And a lot of this chapter is really about getting you thinking about that. Most people, these databases can be very, they can kind of fool you because they look like they don't cost much money. But when you start storing a bunch of records, especially if you're buying server space from somebody, it starts to become cost prohibitive. So you want to get the best bang for your buck. There's a course that the computer science students all take. It's called Data Structures, and that's what all they do is figure, okay, if I have this type of business and I get this type of data, what is the most efficient way to put together their table, i.e., and input mass data, the amount of space dedicated to it, and what does that really mean? How far do I need, when I'm dealing with money and currency, does it need to be 2 digits? Should it be 4 digits, etc.? And that's all they do, so that they understand those options. Now you have them there if you have the GUI like we're working in, and this is going to be something you can tailor to whatever you want to do, but it just depends on what works for you and how you want to see it. It's just an issue of formatting it. That's all it is. The indexing is the stuff that's far more important here. So they talk about creating sequences, and it's over on page 256 and 57. And then over on page 260, they talk about creating sequences in a table, all right? Now, a sequence is really nothing more than a predetermined set of records and that the sequence of them is determined by some factor. Now, if you look, for example, let's look at this this table of employees, okay? In fact, to tell you what, let's play with this for just a second. And then click on the employees table and click copy, and then paste it. And we'll click copy. We want the structure and data. Okay, and so we should find that copy of that table. So we'll go down here. There it is, copy of employees. Now open it back up in design view. Now I've got the employee ID, and the employee ID is the primary key. How do I know that? Exactly, because I see the key listed there. Now, the employee ID is a number. And let's go back up to the data sheet view and take a peek. Okay? And we have those numbers and they come in sequence. Now, this is important because you often can link sequences or sets of sequences to a particular period. As you start to build these, you create what we call legacy data, and you'll start to find, if you look through legacy data, that you'll find, well, we had about 1,000 of these in 1998 and so forth. And so that's just really, it's useful for us to make sure that it's in an organized fashion. Now, let's go back into the design view of this for just a sec, okay? And if I look at the field size is decimal, and notice I go down here and I'm indexed and I have no duplicates. All right? So it's not going to let me create duplicate ID numbers. But if I want to make sure that I don't have to worry about somebody putting in 600s and 700s and all of that, it's pretty simple. I can put the number in and I can make it an auto number. And if you scroll down there in the data type, we'll call it. And then we'll go back up to the view after we save the table. And you'll see that as I start the next record, and I put this in Paul, okay, and I'll put, Hoffman. I'm just going to fill this out. And we'll put them in sales. And enter value copy. Okay, so we need the employee ID field. And we'll put, this should generate an auto number for us. We may have to close the table off to do that. But I'm gonna save this and see if it's gonna save for me. And then I'm gonna try to close it and see what happens. Not too bad, it did work. Let's go back here for just a second. Now, as I come down, I should get an auto number with each of these. In other words, it should just automatically generate a new number for me. I didn't save it and keep it there in the auto number. No, okay. You're not going to play nice with me tonight. But with auto numbers, it just generates the number so that I have a sequence. I do have some protection here if I say no duplicates, but it can get confusing if I start putting in 300s and 400s and 500s, although I could do that if I chose to do it. That's all that's going on there. The text talks about over in 262, 263 about creating an index, and then it talks about the optimizer, okay? And there in page 264 and 65, it talks about how an index works. That's going to be some interesting reading for you, okay? But not essential for a very simple reason. Most commercial products are built with an optimizer to ensure that you get the maximum benefit of their product, and to keep a database administrator or programmers from getting in there and tinkering with the things. And an optimizer, just simply what it does is it figures out, where do I search first to find what's the most likely area within a table or within several tables that have been linked together to find the information. Okay? That doesn't sound like much, but if you start talking 10 million, 50, 100 million records, then you want something like that operating. And we found that we had to do this because we're storing so much data that if we don't have these kinds of mechanisms inserted in the software that's under the software you're looking at, it's going to be a nightmare, and it will be slow trying to get the data out. So that's all that's really going on there as far as the optimizer. They give you and then they talk about the data dictionary, Oracle's data dictionary. Of course, in Access, the data dictionary is right here in this design view. you will hopefully be fortunate enough that you'll go to work and you'll have an IT department or maybe a vendor, and you'll have some good supporting software or BI-ware to work with, and not really have to worry about a lot of this. Your worries will simply be, am I understanding what I'm seeing? And we're trying, and folks are trying to move things to the point where you as the decision maker, you recognize patterns, okay? Since you see a pattern, you go, oh, okay, I see that it's going up. And so you're gonna see more and more of the dashboards like we saw with the Northwind traders, but they're gonna be iconic, and that's gonna be, they're gonna be more like infographics than giving you numbers. And you see this in airplanes. They have an altimeter, but they also have coloring and marking to give you a sense of, am I running myself in the ground, or am I ascending? And they'll also give you some visual cues on, like if you're banking right or you're banking left, you get the same visual cues. You can get terribly confused up there of whether you're going up or down, right or left. Even a pilot can, unless they're really paying attention to the instruments. Because when you're up there and you're flying around, and I've been up there, I've flown a lot. I'm not a pilot, but I've ridden a lot. My dad had planes. I've done a lot of flying, and flying with folks, and I could tell you, you can get disoriented very quickly. So you have to have the instrumentation, and that instrumentation is getting more and more iconic, so a person can just look at it and say, oh, okay, not good. Oh, so good. Okay. They talk about the data dictionary, the indexes, and all that bizwax. And most of this is in with Oracle. Now, you say, why does Access not have something like this? Well, they have a couple of things out there like Northwind Traders, kind of demo products. But Access, when Microsoft put Access together, they figured it was really more for amateurs and for people that were learning database. And that's true, because the commercial products that are out there are far superior. And if you're a decision maker, you're kind of just dealing with the top level, the stuff that's at the desktop. You're not messing with anything on the bottom. And it's going to be rare. It's going to be rare that most of the time your interaction, and hopefully this course will help you, your interaction is going to be when you get anomalous data. And that is, you say you get a whole bunch of null data, or you get some data and they don't add up, or you get repetitive data. Say you get, you want a printout of the employees' birthdays or year of birth, and you get all 1967s or something like that. That's where if you could have a pretty good conversation with IT people, i.e. your vendor or the internal people, you can get that type of problem solved pretty quickly, because there's something going on in terms of the table, probably in terms of the data definitions. There in 279, the author walks you through a whole series of inserts, and the result is right there at the very bottom. That's a lot of work to get 3 records, a bunch of work. Does that make sense? Yeah. So we're not doing a lot of this cut and pasting tonight, because a lot of this is more conceptual material. And again, it will be rare for you that you will be constructing some of this stuff. Here's probably what will happen is your boss will ask you to run some queries. They'll say, hey, I need to know about the number of cantaloupes we sold in Chicago on each Wednesday for the past 5 years, and some crazy kind of request like that. And that's when the challenge will be for you to go back and say, I don't have access to the tables, or I need to work with that. And typically what will happen in those kind of serendipitous queries is you'll find some holes in your data, or you'll find that you're going to have to do a little bit more work with the tables, or maybe you don't have the data at all to satisfy that type of request. It's easy when you've got this tool in front of you to overdo it, and that is to run too many serendipitous queries. And what I mean is just, hey, what about this? What about that? You really do need to have a disciplined approach to get that done. And typically that's going to be, a disciplined approach is going to be, I'm going to drill down, okay? And then I'm going to drill across and use row summaries. And then I'm going to take that information that's been distilled, because I should have all these columns, and then I end up with a small table. Remember those little squares that we had that I pulled out? And then I take that and I try to visualize it, or I try to summarize it in an application that can do that for me and do it quickly and do it well. In other words, snatch a bunch of stuff from your database, and if you have an associated spreadsheet or analytic engine, throw it in there, or throw it in Excel. That's like when we did the exports. We did 2 exports on that Northwind data. We exported a fact table, and we exported geographic data. And that'll be pretty much the typical experience you have. So all of these queries he has you run over here on page 279 is just, there's just no point. It's just fruitless. So you have these few 7s that we. Okay. Let's go over and take a look at chapter 8, because this is where we do have the rubber meet the road, and that's over on page 282. You with me? Okay. So when you get ready to, now what I'm going to do right now is I'm going to save this. Okay. And I want to save this object as, you're not going to let me save you? Well, you little weasel. All right. Anybody else having this trouble getting them to save? No? Huh? Oh, let's see what we got going. Save as. I'm sorry. There we go. Always helps to have somebody sane in the room. I'm going to call this LD7 and 8. We're going to spend a little bit of time on data integrity. Now this one is extremely vital, so we'll want to kind of have our ears on. I'll enable the content on that. Let's pop back up here. Okay. Now, if you want to get a good overview of this, and you can go over and take a look at page 282, and they're going to walk you through constraints, referential integrity, delete options and update options, variations of referential integrity, and then code constraints. Okay? The 2 things are, first of all, you put constraints on your table. You only allow information to be inputted that meets a certain criteria, which is typically going to be a format that you want and a data or content of data that is valid, that works. Okay? And normally how we achieve that is we'll use backup tables to do that. In other words, we'll use a lookup table. Now, let's go over, and I'll give you an example. Let's go over to the employees table and let's open it up, okay? And we've got their first name, blah, 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 their hire date, okay? Now you'll notice something. I've got these department codes. Do you see those? If I want to put a constraint on that and ensure referential integrity, then I would have a lookup table of department codes. I'd have this short little code, and then I'd have it filled out for what it means. And that way, as I click on here, I get a drop-down menu. You'll notice when you go buy stuff or you go online, you get a lot of drop-down menus. And the reason you do is to ensure the integrity of the data and to put constraints on it, so that a record has a size you can reasonably predict, plus you make sure that it's the data are that you have good or authentic data that work for you. On the hire date, for example, all right, you could put a constraint on that where you don't have any entries before I guess 12/1/2008. Because if I started the company on December 1st, 2008, then anything before that's invalid. And I want to have that constraint there. Why? Let's say that you have somebody and you don't have that constraint, and you have somebody who decides to create 2 or 3 employees and send them a payroll. And you get stung for a bunch of money. Or a vendor that gets created who's not really a vendor. They're just somebody that's been entered into the database, and then you're sending them checks. Okay? Or you're getting returns from them. The referential integrity in that and putting that constraint stops that kind of thing. Especially if you have somebody adding ghost employees and things of that nature, for the simple reason. You'd stop at 6198. Now let's just go ahead and put those in. I'm going to put those in oldest to newest. And so I would know that anything before this is not valid because we're operating. Does that make sense? Over on the bottom of page 284, they show us, and this is in the section 802 foods table. So let's close off this employees table. We'll close it. No, I'm going to save the changes. And which table are we working with there? We are in the section 802 foods. Okay. Let's go back over there for a sec. And I'll show you what we're talking about here. If you don't have good referential integrity and you don't have good constraints, then the ability to leverage what we call the law of large numbers, and that is run data queries on 1,000 tables or 10,000 tables or whatever, just isn't going to take you anywhere. And we'll open that up in the design view. And there, if you take a look at the bottom, you see the GUI. You've got a supplier ID, you've got the product code, you've got the account number, the product code, you've got the menu number, the description, the price, and the price increase. Now notice there that they have the price is in currency. Okay? Now click on the price, and you'll see the field properties. And this is at the bottom of page 284. And they've got them in currencies. The decimal places are automatic. Okay, that works. And then you come to a validation rule, and you have and that validation rule says it must be less than 10. You see that? Then you get what they call the validation text. And that will tell you if what the error or the problem is. So if you violate that rule, it'll pop up and give you a message. It'll say, it's got to be less than 10, or the price exceeds 10. The price, there it is the price exceeds $10. And that way you've got a control on it. So it's a way to make sure you've got valid data and that you've got referential integrity as well. Talk about that for a moment. in this section 080 foods table, how many primary keys are there? 2. Why have we got 2 primary keys? What do you think? Is it possible that we might carry mustard from 2 different suppliers? So if I'm Walmart and I'm carrying 2 different types of mustard, let's say my house mustard, whatever it's called, and then Heinz, for example, then I'm going to have the same product code, but 2 what? 2 different suppliers. So one of the ways that we ensure that we have the integrity is we make sure that we're aware of any one-to-many or one-to-infinity kinds of relationships. If you look there and you see, for example, the product code, it's mustard, for example, okay? I don't know what it is. It's mustard. Let's go up now. We'll go up and see what it is. It's the soup. It's fresh salad. Yeah, that's not a very good example. So we'll stick with mustard. Okay. And I've got 3 people that send me mustard. I can have 5 people that sell me mustard, supply it to me. So I'll see that dual key there to make sure that I have data integrity so that I know that one particular mustard, I know how they're differentiated on the basis of the supplier. And in this table here, for example, that product code might also be driven not just by the type of product, but by the size. I might have a table for mustard that says, okay, here's mustard, 10-ounce glass dispenser, plastic dispenser. And Heinz may sell me all of that, whereas my house brand is just mustard, so many ounces, plastic. You got me? Now, if you're a marketing student, you really want this to make sure this is working. So when you start to look at sales data, you know that you're getting good information. If you don't have these kinds of safeguards built in, you have junk. I think it's good for you to see this so that you understand when you look at a report, you always want to be looking for anomalies or anything that looks like something is amiss. In this case, you ought to get a good report because you've got these 2 keys here and you've got them differentiated. You've got a good thing as far as price, and you're good to go. Could you have a price? You have price and you have price increase. Could you have price 1, price 2, price 3, and have validation codes on each of them? Absolutely. You'd want to. If you're selling it at a certain price, you want to make sure it's sold at a certain price and not at too high or too low a price. So that's what's going on there in terms of some of those constraints and using the GUI. And they talk about using a unique constraint. That's what we just got through talking about. They go down to the phone number there. What table are they? Let's go over and take a look at 0803 employees. That's going to be this next table here. It's section 0803 employees. Let's open it up for just a second, okay? And let's go down to the design view. And the authors are going to show you there over on page 287, the bottom page 287, you've got the employee ID. You should have the employee ID, and it's a number. Okay, and the next question is it going to be a unique number? Are you going to have an index, etc.? Click on the phone number, and they have short text. Okay. And on that, you'd want to use an input mask. if you were limited, let's say you're a regional operation and you're limited to, say, a certain state area that has certain zip codes, you probably have added in, if you put in an invalid zip code, it's going to pop up and say invalid area code, and you won't, and you'll go, okay, yeah, here's the number I need, here's the area code I need to use. If you're going to say generate lists of phone numbers, say out of a phone bank. That's really all that's going on with this in terms of chapter 8. A key piece of this up here at pages 287, where they talk about not null. Okay, you're going to hear me talk about this a lot. The question for you, when you get a report, you come in on Monday morning and somebody's running a report, and you see a bunch of empty cells or a bunch of empty spaces, it would be in your best interest to understand if nulls are accepted or not. Because if you don't have a no-null constraint, if you accept nulls, you don't know what you have. You don't know if somebody forgot to put the information in. You don't know if somebody just didn't have the information to give, whatever. When you put in no nulls, that means every single field must be filled out or the record doesn't save. And that is what you want. That's hard-nosed, it's old school, but trust me, you don't want to leave any doubt in terms of the record that you have, especially if you've got stuff like sales records. Because if you get sales records and you start seeing empty cells, in other words, if you allowed nulls, you don't know if they didn't buy anything or you just forgot to enter the number that they purchased. Or there's some breakdown between maybe the form that inputs to that table. You've got to have this stuff if you're going to take these tables and leverage them and string a whole bunch of them together. That's just all there is to it. Over on page 288, the authors give you primary key constraints using them. And we've done that like with the employee ID. Page 290 is probably going to help explain a lot of this as opposed to all the narrative you've got and the verbiage you're getting from me. Notice what's going on here, okay? I've got a lookup table. You've heard me mention those before, all right? And I use that to build referential integrity so that I make sure that I have let's say a lookup table of a simple thing like the abbreviation states. Okay, now there's AL, AR, and AK, and AZ. Which is which? Well, most people get Arizona. Most people get Alabama. What's AR? Is it Arkansas? And is there another one? If you have a lookup table that just says AZ, Arizona, now I hate to break this news to you, but let me give you a secret. Unfortunately for you, you're going to start your career supervising people who on average read at about a 3rd grade level. May God go with you. Because when they're reading at that level, they don't understand directions, they don't follow directions, and you've got problems. So you're going to have to protect input in every possible way you can. You'll need drop-down menus for everything, especially with things like states, things like zip codes, things like area codes for phone numbers. You'll have to use a lot of data masks to ensure that somebody understands that Missouri is MO, not MISS. Because it can get confused easily. You don't, but someone else might. Or if they can't spell. And there's a lot of that. Now, I'm not saying this to be cruel or mean. That's just what you're going to be inheriting and dealing with. And trust me, it wasn't good for me. When I started managing people, they told us the average employee that you have is reading at about the 7th grade level. It's not getting any better. And it's not those folks' fault. So don't blame them. But you have to make sure that you have as much control of that as you possibly can. If you don't, it can end up being a free-for-all, and you have all kinds of crazy information coming out of reports. So you want to maintain that integrity. And that concept of RI is simple. Because I have that lookup table, okay, the data table, as I mentioned there, it's also called the child table. They use a foreign key. A foreign key is a primary key in another table, and you use that to link the tables to ensure that you have referential integrity. To make sure that when you run a report on your customer, okay, and you have a customer's table somewhere that's created that has the contact number and all that and has their unique ID, that when they say, I'd like to see my sales history for the past 20 years, you can bang it out right there and give it to them. Okay? And so they could say, well, here's what we've been selling you for the past 25 years. And hopefully you'll have a client application that will also kind of give them a nice, pretty picture that you can give them a nice report and look at, because people like pictures and they recognize images. Oh, I've been buying a lot of your stuff. Now, there's one or two things coming on that one. One, unfortunately, I need a deal. This is your customer, the voice of your customer. Or, gee, we're getting ready to launch an initiative and we've had such good luck with you. We're going to buy twice as much as we did before. Now, that's the one you go home and go, hallelujah. The first one, you go, okay. And you go run to find out who can give you permission to give you a deal if you can give them a deal. But you'll need the report to be able to do that. So they'll walk you through the concept of linking that using the lookup tables, okay, to create the data tables to give you those reports and do the extractions. And they walk you through setting up some of those constraints. They show you at the top of page 292. And then inserts and updates, and that are allowed by RI. And they've got several update queries. They're at the bottom of page 296, 297. And if you look at 298, you'll see some more. And here's where you're updating what they're doing there in the middle of page 298. They're updating. They set the state code to ZZ, meaning it's 2 characters. So you set the state code for California to CA, because you want to cut the space down. Anybody know the state code for CO? Connecticut, is it CO or CT? Okay, Colorado is CO. Kind of got to stop and think, don't you? And if you got 250 records to put in, you may not stop and think. That's why you want to use forms and make sure those forms are highly structured. You're the ones who get to come in on Monday and encounter a workforce that, over the weekend they had one too many Red Bulls and a couple of domestic disturbances, and so their mind's not really on their work. And you get to take them forward. God bless you. You too will have the wonderful experience I have every day of saying, anybody think about this? Silence. And you'll be sitting there going, And if it's in the if it's in a meeting with people that can advance your career or can move you up in the company, and you sit there and you go, the dog ate my homework. Want to be one of your better days. You want to be prepared. You don't want to be too anxious, but you don't want to sit there like a water fountain waiting for someone to punch it. And be prepared with the answers. Be prepared. Have your reports. Be ready to go. I know. You tell yourselves, well, when I get out there for real, I'll do it. We'll see. We'll see. I hope you did. You'll get to experience that feeling. Now, those inserts that they've got there, the insert and the updates and then the deletes they've got there for 813 are pretty self-explanatory. They're not that, it's not that big of a deal. And I'm just hesitant to have you run the code for the simple reason you could see it. There's the command we're going to insert into, and there's the table that we're going to work with. And then we've got the values, okay? And it starts off with the values ZZ, and California, then Sacramento, and then we update that where we set the state code equals ZZ, where the state code is California. And what that's saying is we're going to use 2 digits anywhere it's California. And so you end up with that. And in any of the codes, it's going to come, that ZZ is going to take it down to 2 letters. That's all that's going on there. The same with the states table. Now, the authors go through kind of a long-winded exercise over here in talking about linking up tables. We've been down that road before, so let's close this table off, okay? And just for fun, click on Database Tools, all right? And let's click on Relationships. Now this shows us the relationships between all of these tables and the type of relationship that they have. Now you'll notice, for example, if I look at suppliers and foods, I have a 1 to infinite relation or 1 to many with the supplier ID and the supplier ID there on the foods table. Why? Well, they need to match themselves up. And then the same thing on the products. This doesn't happen by accident, and they walk you through the process of doing it over on page 202. And let's take a look at this for just a second, and I'll just show you how we're going to do this. Let's close it for a sec. Okay, and let's flip the viewer back. And let's choose departments, 0709 departments. And I'm going to copy, and I'm going to paste it. And then I'm going to get the suppliers, and I'm going to copy it, and then I'm going to paste it. So I've got the copy of suppliers. Okay, and the copy of, I've got the copy of employees and the copy of suppliers. Now, I'm going to click Database Tools, and I'm going to go back to Relationships. And I'm going to find those 2 tables, okay? And I can link them up as they show me there, just simply doing it using the GUI. This is a little bit jumbled in here, so I want to find the copy of. Well, that is a jumbled mess, isn't it? And I just simply take the parent child, which is the parent table, which is on the left, and I just simply link them up. I can do this here with, I've got the lunch items too. And I'm going to do this. I'm going to link up the supplier name. Let's see, the supplier ID. How do I want to do this? Department name to department code. All right. Click on this. And now I want to go ahead, and if you say show you there, you're going to want to link the two of them up, and it should just link up directly from one table to the next. Okay, and it's not going to be nice to me tonight and play with that, but if you notice there, you can click on the edit the relationship, and you can add the two tables, and you can put the two tables together. Don't know why I'm running into this. Probably because I put a hex on myself, or who knows what. Let's see if I can find this over here. Quantity, department code. And well, that's what I'm going to try to do if I can get to the edit relationships. Now, the ones that exist already are no big deal. If you want to see the edit relationships, click on that. Just click on the line there, and it'll show you that. Okay? We've already got the relationships. What I'm trying to do is connect the two tables together that we had, and it's not playing nice with me. But this will help us anyway, so let's go ahead and see it. What I have is the employee ID and the manager ID tables, okay? And what that's telling me, it says enforce the referential integrity, so make sure they always match up, okay? And then I click on a thing called the join type, and this is going to tell me whether I have an inner join, a left outer join, or a right outer join. You're saying, what do you mean? Watch. Only include the rows where the join fields from both tables are equal. So if they're equal there, you join them. You do an intersection. Okay? Now, a left-hand join is where you take all the records from employees and you pull those, and then you pull only those records where employees match with the other table. And then you include all the records from employees. That's the right hand, and then with the employees one. So you basically have a couple of, you have an straight intersection, then you have an intersection where you have everything in one field, okay? And think of a Venn diagram, and think of the left-hand side, and then you have a match between it where they match up, or on the right-hand side. So it's a left or right-hand joint. And those are just, it's a matter of choice. Most joins are going to be inner joins. It's where that you're going to do a left or a right. So cooperate with me tonight, but that's all right. Deletes, stay away from that. That'll get you fired. And over on page 307, this is over in chapter 8, you're going to see that they talk about the levels of referential integrity, the applications of it. And you'll see in that figure there, you're going to see that it says enforce referential integrity, and then it says cascade update related fields or cascade delete related records. If you have true referential integrity, when you update one record, when you run an update, it'll update everything. Or if you delete, it will delete everything. You have to be careful with that, and that's really the province of your database administrator, not you. Leave it be. If they say it's updated, then that's fine. We can go back over here for a moment. And let's go ahead and we'll get the edit. We'll click on that one of these lines, edit the relationship, and you'll notice if I enforce referential integrity and then I choose both of these, this means any change I make updates all of the records in my database. You want to be very careful with that. That is not good, could create problems for you. Okay? Anybody have a question? It's kind of conceptual stuff, and it's a little bit dry, and I know that. The authors give us some discussion there about different uses of primary keys and using two or more. I'm not sure that there's all that much left in that. And what I'd really rather do is this. Now, I want you to take a look at this, and, and I'm recording it for that reason. However, when I do part 2, I'm going to look at row functions, and that's chapter 9 on the row functions. And I'm gonna and that I want you to pay attention to, because that's where we start to really collect some data. We're going to look at row functions, then we'll look at column functions, and then how to take those data out and do something with them in an analytic engine that's going to make a little bit more sense or be a little bit easier for us to work with. So you want to, what you've been working on here tonight, you want to save, okay, on your data on your desktop, and then upload it for 7 and 8. For 7, and then also upload it for 8 if you wish. Okay? Now I have some data, I think I have some 7 and 8 examples there for you as well. And like I said, we're moving ahead pretty fast. There's no break there. See, then we come into week 8. We're already in week 8. So I've got a lunches DB7 there if you want to upload it, or you can upload the work we did tonight for that workshop credit at the same thing as lunches DB8. Now I'm going to spend quite a bit of time with 9 in the part 2 of this, because I really want to get you focused in on row functions and why we use them and what they do. And they'll just make a lot more sense to you. A lot of this is stuff that's nice for you to have a sense of and understand, but not so critical or vital that you're going to be not able to function out there if you don't have it. So that'll pretty much do it. Anybody have a question I could try to answer for you? Yes?
How many primary keys can you have?
Well, I'd say based on the complexity of a database, I think if you have 4 or 5, you've got an exceptionally complex database, and you're collecting a tremendous amount of data on somebody or some bodies or things to such you've got to be getting it down to such a detail that, gosh, I guess you'd probably have, if you had 4 primary keys, I think you're going to be talking about as many as maybe 12, maybe a dozen, maybe 15 dimensions in a table. And I don't know in the kind of tables that we work with where you would see that. I think it's going to be more if, say, you were working in the physical sciences and you had a database that you put together maybe of cell structures or something of that nature. But in business, 2 is pushing it. But and two's about all that you're typically going to have in terms of dimensions. I mean, it's pretty simple in business. Who, what, when, where, how much, how often. And you know that stuff, and you throw that in the database, you can pull out, then you can analyze it and put it in graphic form. That's about 95% of the game. So it's a good question, but yeah, that's beyond 2 in business. It's just you have to have something that's so finely, you'd have to have something so finely tuned, so finely cut up that it really makes sense to have that many keys. Okay. All right, folks, thank you so much. Anybody else question if yes or no? No? Yes? Okay. I'll do part 2 over the weekend, and that one you really want to pay attention to because I'm going to be working on row functions